viewers, welcome to today's lesson. Today we are going to look at geometric progression. A geometric progression, which is also known as exponential sequence, is a sequence where each term is obtained by multiplying the preceding term by a non-zero constant. Okay, so take note of this information. The preceding term must be multiplied by a non-zero constant, and this term is called, the non-zero constant is what we call the common ratio. All right, now this GP can be generated. Okay, this can be generated by the first term A, and we have the second term AR, the third term AR to the exponent of 2, and the fourth term will be AR to the exponent of 3. So this sequence continues to AR to the exponent of n. Now, where, let's say, A is the first term and R is the common ratio. Right, now we also need to know that R can be generated by dividing the second term by the first term. So what I mean there is, if we have R, we can find the value of R by saying A2, that's the first term divided by the second term divided by the first term, which is the same thing of saying the third term divided by the second term. Now in our case, R here will be AR divided by A, and this can also be AR squared divided by AR, and it continues. All right, now we also need to know that the nth term of a geometric sequence is given by the expression UN equals to AR to the exponent of n minus 1. A represents the first term, R represents what? The common ratio, and n is the nth term. Okay, when we say the nth term, the number of term. Okay, let's put it this way, number of term. All right, now let's take a look at illustrative example. The first question we have here is determine the nth term of the GP, which is given to be 2 minus 6, 18. Now from the question, we know that A is given to be 2, which is the first term, and the common ratio R. Remember, I said that the common ratio can be obtained by the second term divided by the first term. In our case, the second term, this is A2, and this is our A1. So minus 6 divided by 2 will give us minus 3. So we are to determine the nth term. So we use the expression UN equals to AR to the exponent of n minus 1. Now UN here will be equals to, the A is 2 and R is minus 3. So there still remain n minus 1. So the nth term will be 2 times minus 3 will give us minus 6 to the exponent of n minus 1. This can also be written as n equals to 1 over 6 to the exponent of n minus 1. So this will be the nth term of this given sequence. Now B says we should find the third term of the given GP. Okay, so we know that UN is given to be 1 over 6 to the exponent of n minus 1. So U3 will be equals to 1 over 6 to the exponent of 3 minus 1. And so this will give us U3 equals to 1 over 6 to the exponent of 3 minus 1 is 2. So this will be U3 equals to 1 over 6 to the exponent of 2. And this will give us 1 over 36, because 6 squared is equals to 36. So we can say that therefore u3 is equals to 1 over 36. All right. Now let's take a look at another example. Example 2. The first term of a GP is 16 and the common ratio is 1 over 3. Find the fourth term. Okay, so the first term A is given to be 16 and the common ratio R is given to be 1 over 3. So we have to find the fourth term, N equals to 4. Alright, now we know that the n term is given by the expression un equals to ar to the exponent of n minus 1. Now we are going to find u4, which is u4 equals to, the first term in this case is 16 and the common ratio is 1 over 3. N minus 1 will be 4 minus 1. So the u4, that is the fourth term, will be 16 times 1 over 3. 4 minus 1 is 3 and goes down, so this will be u4 equals to 16 times 1 to the exponent of 3 divided by 3 to the exponent of 3. Okay, and when you do that, our u4 will be given to be 16 times 1 to the exponent of 3 is 1 and 3 to the exponent of 3 will give us 27. Alright, so this will be the same thing of saying that the first term is equals to 16 divided by 1 times 1 over 27, so that the fourth term will be equals to 16 divided by 27. So that is the value of the fourth term. Now let's take a look at another illustrative example. Okay, now in this question we have the 7th and the 10th term of an exponential sequence of positive terms 64 and 502 respectively. Find the common ratio. Write down the first 5 terms of this GP and we should find the fifth term. Now from the question we know that u7 is given to be 64 and we also see that u10, that is a 10th term is given to be 512. We also know that the 7th term is given by the expression a r to the exponent of 6. Remember, it's always n minus 1. So the number of term minus 1 and will give us the exponent, and this is equals to 64. Let's call this equation 1. The 10th term will also be given by the expression the first 10 times the common ratio to the exponent of the number of term minus 1. So in this case, this is 10 minus 1, which will be 9, equals to 512. Let's call this equation 2. Okay, so let's say equation 2 divided by equation 1. We are going to have it to be a r to the exponent of 9 divided by to the exponent of 9 divided by ar to the exponent of 6, and this is the same thing of saying 512 divided by 64. Now when we compute this, we know that a is gone, so we are left with r to the exponent of 9 using indices property, out to the exponent of 9 minus 6. Indices property, when they divide we subtract their exponent, and 512 divided by 64 will give us 8. So here we are going to have r 9 minus 6 is 3 to the exponent of 3 equals to 8. Okay, now let's take the cube roots of the both side of the equation. So this will be r to the exponent 3, the cube root of r to the exponent of 3, and the cube root of 8. Okay, so basically this and this is gone, so we are left with r equals to the cube root of 8 is 2. So we can say that the common ratio r, therefore the common ratio r is 2. All right, now the next question says we should write down the first 5 terms. Now before we write down the first 5 terms, let's find the first term a. So a will be, we can find a by saying that from equation 1, let's use equation 1, a r to the exponent of 6 equals to 64. And what is a? We don't know. R is 2 to the exponent of 64 equals to 64. Okay, now when we express those, we are going to have 2 to the exponent of 6 will give us 64. So we are going to have 64a equals to 64. Now dividing both sides by 64, we are going to have a, the first term, equals to 1. So in this equation we see that the first term is equals to 1. Now recall that to generate any term of a geometric sequence, we need to multiply the common ratio by the first term. So we know that the first term is 1. Now the next term, common ratio, this will be 2 times 1, which is 2, and the third term will be 2 times 2, which is 4, and the next term will be 4 times 2, which is 8. The next term will be 8 times 2, which is 16. So we can say that the first 5 terms of the sequence is 1, 2, 4, 8, 16. All right, now let's take the last one, which is the third. We should find the fifth term. So we know that the fifth term, that's, let's first the n term, equals to what? A r to the exponent of n minus 1. So the u5 will be equals to our a, the value of a is 1, and the common ratio r is 2. So this will be 5 to the exponent of minus 1. And so when we move on, this will be u5 equals to 1 times 2. First, let's do this 1, and this will be 2 to the exponent of 4. Okay, and so this will be u5 equals to 1 times 2 is 2, and so this will be 2 to the exponent of 4. And u5 will be equals to 2 to the exponent of 4 is 16. So we can say that the fifth term of this sequence is what? 16. All right.